The short answer is that you want to use this matplotlib function called fillBetween, which allows you to pass in the x values that you want to fill and the y values that you want to fill. And then essentially it allows you to pass the area that you want to fill under the curve, and it fills it with this color that you set here, so R for red, right? Long answer, I'll walk you through my thought process from the beginning. So just ignore these libraries, I'll talk them through as I need them. But when I start thinking of this, I think, okay, what do I need? A normal distribution, what do I need? I need a mean and standard deviation. I decided to work with a standard normal distribution. What does that mean? It just means that the mean is 0 and the standard deviation is 1, right? That's true for the standard normal distribution. So what does mean is equal to 0 mean? No pun intended. So it means that the average is 0, meaning that most of the values in a normal distribution is going to be centered around 0, centered around the average. And you see that over here, that most of the values, a lot of them are centered around 0, and then they start dissipating in both directions infinitely, and they can start getting smaller, right? And then standard deviation set to 1 means that every value has a distance in between of just 1. So it's basically how far all the data points or all the numbers or all the x values, however you want to call it, deviate from each other. So if I change this to 2, you'll see that it'll go from 0, 1, 2, 3 to 0, 2, 4, 6, because now each number deviates 2 units from each other, or 2 numbers from each other. So you do 0, 2, right, distance 2, then you do 2, 4, so there's 2 units, 2 numbers in between there, and that's how much they deviate. But I'm going to go back to 1. So that's kind of what that means. So then now that I have my information, I have my mean and standard deviation, I'm thinking, okay, I need to plot the graph. How do I go about doing this? Well, to plot any graph, you need values, and specifically x and y values. So I did plt.plot, right? My x values and my y values. Plt.plot is a matplotlib function. Well, plot is a function. Plt is the library that I imported, and it's just matplotlib.pyplot. It's just a visualization library, right? So then going back to the point of x values and y values, how do I get those? Well, let's start with the x values. I set my x values equal to this function, a function that comes from the NumPy library. So NP is just NumPy. I just imported the library NumPy as NP. It's just a numerical library. And linspace is a function that allows me to get an array of numbers, right, that I can actually use as my x values for my normal distribution. How so? Well, it allows me to place a starting point of where I want my array of numbers to start. And by the way, I'm going to say list just for informal speaking, although it's literally an array, but just so that it's more intuitive, I'm going to say list. So basically, np.linspace just returns a list of numbers, and it allows me to say, okay, where I want that list to start. And so I want it to start 3 times the standard deviation to the left of the mean, right? So I want it to start to the left of the mean 3 times the standard deviation. 3 times the standard deviation is 3, right? Because the standard deviation is actually 1. So I'm saying I just want 0 minus 3. That's where I want this to start. So that's negative 3. So you see at the bottom that you see that it starts at negative 3, right? And then the stopping parameter, I said, okay, I want it to stop 3 times the standard deviation to the right of the mean. And so this means it's 0 plus 3, because again, the standard deviation is just 1. So 3 times 1, 3. 0 plus 3 is 3. So it starts at negative 3, and you see that over here in the graph, and then it stops at 3. And this could be any number. It doesn't have to be, just 3. It's just that the bigger this number gets, the more constricting the graph gets, because the more, because again, it's continuous and it's infinite and it's just going, just infinitely, but you don't really see any values, because again, the whole point is that you really want to be centered around where most of the values are, and that's 0. So you want to kind of keep it symmetrical. So that's why you want both of the numbers to be the same, right? So that's why it's supposed to be 6 and 6 and 3 and 3. And then 2, that's why you want to keep it a little bit closer to whatever your mean is. So if your mean is 0, then, I would kind of go with 3, because that's standard. And then the last parameter, num, is how many numbers you want. So I said 1000. So I'll actually go and output this, paste that in here, this is what it outputs, right? It outputs an array, right? Literally, it's an array. I'm saying it's a list, but it's an array. It starts with -3 and it ends, if I scroll all the way down, with 3, right? And there's 1,000 values in between. And so these are my x values, right? Simple as that. Now that I have my x values, I have to move on to my y values. So my y values are essentially based on my x values, right? So what do I do with my y values? So if you think about it, a normal distribution, right? The y values are the density of those, the probability density of those x values, of each and every single one of those x values. So what I did was I used norm.pdf. Now, norm is the equivalent to your normal function in your calculator. So in your calculator, there's like norm, there's normal CDF, normal PDF. So for me, I did normal PDF because I'm trying to find the probability density function of each of the numbers in the x values, right? Because the x values is just an array. So I'm passing in this array of x values and I'm telling it, okay, I need you to find the normal probability density function, or I'm sorry, the normal probability density of each of these x values, right? And I took this function from scipy.stats, right? So scipy.stats is, well, scipy is a library, and then .stats import norm. I'm just importing the function norm, okay? So then I also have to specify the mean and the standard deviation. So loc is just the mean, and the scale is the standard deviation. The way I remember this is that, well, scale is the only one that starts with an S, so standard deviation starts with an S, so they both are the same, and whatever's left is just loc, right? That's how I remembered it. So yeah, so basically I'm taking the probability density of each of the x values and I'm plotting it. And so those are basically the blue line over here. So just think of the blue line as let me reload. I had it as like 6 still. Think of the blue line as infinite dots. So each of those dots is like a y value. So every time, for example, if it starts at -3, right? It's literally plotting like a blue dot, and that blue dot is the probability density of -3, right? And we could actually even figure what that is actually. So if I do norm.pdf and I pass in -3 and I put in my loc, set that as my mean, my scale as my standard deviation, I'll see that it's a very low number. It's 0.0044, right? It's so low, and it makes sense because in the graph, the the graph actually starts really low, about 0, and so it makes sense that it starts there, right? That's the probability density. And so you can think of the y values, not the y values, of this norm PDF function, just basically taking all of these values and plotting them each and every single one of them until it looks like a line, right? Because there's so many, there's 1,000 of them, right? And so that's what the norm.pdf is doing. It's plotting all of the numbers in the x values array. So it's plotting all the x values, given that the mean is 0 and the standard deviation is 1. Okay, so then at this point, now I can use plt.plot to plot my x values and y values, which is perfect. Let me actually delete this and show you what it looks like. That's what it is, right? It's just plotting the simple curve, the normal distribution, right? But then here comes the fill part. So if I want to fill a certain area, right, between or a certain area in the curve, I think of it as just plotting another like graph. So it's kind of the same format. I have like my x fill, or at least my x values that I want to fill, and then the y values that I want to fill. And it's literally the same thing. It's just that except of telling it to start at -3 and then end at 3, I'm just telling it where I want to start shading and where I want it to stop shading. So for me, I said, okay, I want you to start shading at 0, right? And I want you to stop shading at 2. And then num, I just put there because it's just 1,000. I don't even think I have to put it there. Let me see if I could delete that and if it works. See? Yeah, I don't have to put it there. So start at 0, stop at 2, right? Those are my x values. I'm telling it to fill those x values. And then for the y values, I'm basically telling it to do the same thing, to just recalculate the probability density function of only the x values that I want to be filled, and then given the mean and standard deviation. right? So it's basically like plotting a graph within a graph. So it's like doing the same thing again, it's just that I'm doing it for only the values that I want to be filled. And the only difference is that I'm going to use this function actually, plt.fillBetween, pass in the x values, pass in the y values that I want to be filled, and then the color that I want to be filled is red, right? So it's kind of, again, I think of as plotting a graph within a graph. So this is the original graph, and I'm just basically kind of reiterating and just being more specific on the values that I want to be filled. And then this is a function that actually does the magic, does the thing, right? And it actually takes those two values or those two set of numbers, because this is an array, and then this I believe is also um, an array, and it fills those array. I'm sorry, it fills those or that area. It fills that area with that color that you specify, and so that's kind of what it is. That's the idea. So, for example, if I wanted to, let's say, start at -3, and then maybe stop at, I don't know, -1, I could also do that. So the norm.pdf is just recalculating the probability density values, the y values, right, of these x values here. So -3, 2, and -3, -2, and -1. It's calculating the probability density of those values and just basically plotting them. And then I'm using fill in between, right, to get that area filled with the color red, right? So that's kind of what it is. I also wanted to mention that it's inclusive. So this stop, -1, is inclusive. So if you put -1, it's going to stop at -1. There's another method in doing this. It's or range. Actually, let me show you. Look, I did a little bit of experimenting today. Let's see if I can find it. Right, so NP data range. It's the same thing, except that, if I do like 0, let's say I change this to 2 or something. So, okay, ideally I want it to stop at 2, but it actually doesn't. It's actually not inclusive. It actually is exclusive, the stop parameter. So if you wanted to stop at 2, it's really stopping at 1. And I think the fact that this step is basically how many increments are in between each of the values that you're plotting. So if I do something like 1, not that this matters actually at this point, but if I do something like 1, there's like, it's more, I guess, space in between the values that you're plotting, so a lower step is good for these type of things when you're using NP data range. So it starts at 0, same thing, but then stops at 2. It doesn't actually stop at 2 because it's not inclusive. It doesn't include 2. It actually stops at 1. And then step is basically just kind of, if you want it to be better, be filled more, just do a lower step. I know that there's, let's see, there's moments where a step of like a high step is good, and that's when there are higher, or like when there are more numbers. For example, if I'm starting at 79 and ending at 86, well then yeah, it makes sense to have like 1, but putting it lower I think wouldn't hurt, right? Not that it's necessary, but 0.1 wouldn't make a difference. What would make a difference is if I did like 100, that I'm saying, okay, there's going to be more, right? There's going to be more spaces in between the values, and that's not what I want, right? So that's kind of something I wanted to mention. Either way, I figured I didn't really like that, the fact that I had to kind of think about those things. And so I just kind of experimented and was like, okay, well, np.linspace also works, and I don't even need to put in steps or whatnot. Um, so yeah, for me, this works over here, and it makes much more sense to me because I'm thinking, okay, I'm just literally just doing the graph again, except that I'm just being specific to where I want to fill, you know? And yeah, that's it for today. Bye.